My name is Nasser Syed. I work for the Quorum Labs. I'm one of the uh, lead scientists out here. What we're doing right now is just taking out some media out of the autoclave. We are trying to culture some of the bacteria which we've recently isolated from some of the soil samples we've received. This is more of an experiment because most of the bacteria you find in soil naturally are not culturable right now. So we're trying to figure out what's the best way to go around that and culture at least some of them, if not all, and then use them for further studies and also try to understand how the soil ecosystem works. Essentially, this is our prep area, most of the wet prep area for preparing the lab media and getting all the contents in the right way. We have the measuring scale or the weighing scales, and we do even have a small sonicator for trying to extract some of the proteins and molecules from the bacterial cells and understand how they interact with each other and how the metabolic pathways work with different sets of bacteria. This room is essentially a clean room. We try to keep it under pressure. We have two laminar floors. One of them is certified for level 3. This is the place where we actually run most of the operations, culture work, aseptically transfer all the contents required and try to grow them and see what kind of media requirements have to be met before you get a good culture. And these cultures are again later on go through some more tests to figure out what exactly they are in terms of identifying what the properties are, identifying what genus and species they are, and in the larger picture try to understand how again they work in the soil to maintain the soil as it is. When we don't add any chemicals in there, and when we add any chemicals in there, how these things change, how the populations of this bacteria change, and how they impact our agricultural ecosystem. This essentially is one of the major pieces of equipment which we use. It's a real-time PCR. What we essentially do here is try to identify those genes which are being actively expressed by the bacteria, especially the ones which are essential in maintaining the soil conditions, which we're still trying to understand. There's a lot of gap in the available data and on how we understand the soil ecosystem works. This is a part of one of the smaller steps which we use. And once you figured out what kind of genes are being expressed and in real time how much you can quantify out of that, this is again taken a step further to look at how try to understand how the bacterial systems interact and in a given sample what kind of different bacterial groups exist. Not only bacterial groups, but also we try to look at the different small biota, including fungi, algae, and nematodes, and maybe even smaller protozoans and things like that. In the larger picture, what we want to understand is in a healthy soil how the systems work together to maintain the soil ecosystem, and this is where our NGS station comes in. This is a regeneration sequencer which we're using for metagenomics, where we're trying to understand the what kind of population, what kind of different groups exist in the soil, because most of them cannot be cultured. What we're trying to understand is what kind of different population groups you have, what species do they belong to, and based on that information, again, we try to find out what's the role of that particular species in this soil ecosystem. That gives us a better understanding of how to approach the issue of agriculture in terms of agricultural productivity while maintaining the soil in its natural conditions and healthy. And this is one of the latest systems which we're using right now. This is IONS-5 next generation sequencer. It can be used for a lot of different studies, but most of the time we use it for our metagenomics. And this is a station which is connected to that again, and this helps in kind of getting the samples ready for the metagenomics sequencing. And that's what we are. We try to put this information and the information from chemistry together and see what best works within given conditions and within given restraints, and how to approach a soil health issue in terms of if soil's got some issues, like let's say it's got a lot of phosphorus in there. How do we deal with this? By using natural amendment, by trying to improve the soil ecosystem in a way that the bacteria and the natural geochemical cycles help us maintain the soil and its equilibrium.